inverse variation we did yesterday, right? That was y equals k over x. These graphs are similar, but they're a little bit different. So the inverse square, excuse me, inverse square variation is y equals k over x squared. And that's why it's called the inverse square, because you're squaring something. Okay, so same as yesterday, number on the top, but it'll be x squared on the bottom instead of x. So I'm just going to have us do these first two so you can see the difference between whether the number on top is positive or whether the number on top is negative. That third graph, I'm just going to skip that for now. If you want to go back and look at it, you can. But basically, the larger the number on the top is, all that does is pull that away from the origin. It would take the same shape, same domain, same range, all that kind of stuff. But it would just, the bigger the number on top, it just kind of pulls the branches a little bit farther away from the origin of your asymptotes. So that's really the only difference. We're just going to sketch most of these today. These first two, though, we're going to plot some specific points. Okay, so I just made up a table for us. And the first graph we're going to look at is y equals 2, but instead of being over x like yesterday, it's going to be over x squared. So if I do 2, and I plug in -2 for my x value and square that, what do you get if you square -2?
Wait.
What?
I thought it was 2.
Oh, wait. You can square it. It's okay to square it. Yeah. It would be 4. Okay. Okay, so all I was trying to get you guys to see there, if you square a negative, right, it makes it positive. So, and then we could, I mean, if you want, reduce that, that's a half. Okay, now, same thing, if I plug in -1, when I square any negative number, when I square any number, it's going to make it positive, right? So this would be 2 over +1, so that would just be 2. Now, if I do 2 over -1/2, if you square -1/2, think about that for a second. I'll show you on my calculator if you want to look. If I square -1/2, I would square the 1 and square the 2 on the bottom, so it would turn it into 1/4. So if I do -0.5 and I square that, that actually becomes 1/4 because you got to square the top and the bottom. If I take 2 and I divide that by 1/4, that's actually going to give me 8. Now, just like yesterday, if I plug in 0, if I square 0, it's still 0, and that's still a problem child. You cannot divide by 0, right? It's illegal. Math doesn't like it. Your calculator will tell you it's an error. So you cannot divide by 0. So that's going to be our asymptote here, just like yesterday. Okay, now the nice thing about this, once I get to these values, if I square a half, it's the same thing as if I square -1/2. So these values are actually going to be identical to what I just did for their negative counterpart. So -1/2 and +1/2 have the same y value. -1 and +1 have the same y value. You always have a positive number on the top, which is the 2. You always have a positive number on the bottom because you're going to square it. So all of these values end up being positive. Okay, so what does that do to what we were doing yesterday in terms of what the graph looks like? So again, if these are decimals, just kind of estimate. So if I do -2/2, I just try and go like halfway between the 0 and the 1. Just estimate. It doesn't have to be perfect. If I do -1, +2, that should be on a nice point. And then -1/2, I just come kind of just ballpark, like halfway between the 0 and the -1, and then I'm going to go up to 8. All right, now this, and I know we just scrapped a couple points here, but this forms a branch like it did yesterday. So it's going to get really close to the x-axis, really close to the y-axis, but it's not going to touch it, not going to go over it. And then the difference between yesterday and today, because we're squaring all these x values, it basically just flips both of the branches to go the same direction. So the other branch would literally be a mirror image over the y-axis. And you guys have these points obviously in your table, but they should just look identical, just flipped over the y-axis. And I'm just going to grab my highlighter real quick. The y-axis and the x-axis are your asymptotes here. So x equals 0 and y equals 0. And I know I don't have the space for this, so forgive me. Let me just jot this down though. What would be, if I look at this graph down here, the domain would be left and right, yeah? Okay, so one of the branches does go left forever. One of the branches does go to the right forever. So I'm going to cover all the x values, just this, not this one in between the two branches, which is just your asymptote. So this is just like yesterday, all real numbers, but we're not going to touch 0. Okay, now my range for this graph, that's how I travel up and down, right? So yesterday we had one of the branches flipped down and one of the branches flipped up. If you just had a plain X. Both of these branches, though, because of the square, flip the same direction. So they both go up. So in terms of telling me how am I moving up or down, this does not point down. It just like points to the side forever. It gets closer and closer to 0, but doesn't touch it, doesn't go over it. So the range for these inverse squares are going to be different than what we did yesterday. You are not touching any part of the graph till you hop over that asymptote. So I'm going to write an interval here. It's just going to be 0, which is my asymptote. And I'm going to use a parenthesis because I don't actually touch it. We just get real close. We don't go over it. And then it's pointed up forever. So it's going to go to infinity here. So you're not just excluding a number when you do the range like we did yesterday because both branches go the same direction. You're not touching any part of that graph underneath the x-axis. There's no negative values there at all. So it's going to go from 0 up to infinity. All right. So positive number on the top. If we're squaring, when we plug in our x values, we're always going to have a positive divided by a positive. Okay, if I switch over to the one right next to it, the only thing I changed up is I put a -2 on the top instead of a +2. Okay, so let me come back over here. This is always going to be a positive number divided by a positive number, which is going to be a positive number. In this situation, let me just do an example here real quick. I'm going to have -2. And I'm going to plug in -2 for x again like we did on that previous table. But here I'm going to have -2. When I put that bottom number in and square it, it's always going to make it positive, so it would be +4. So this would be -1/2. If I plug in, same thing, like if I have -2, -1 squared. When I square the -1, it becomes positive, but I had a -2 on the top, so that's -2. So in this situation, you're always going to have a negative over a positive, which means every single one of those coordinates is going to end up being negative. So it's the same table you just wrote to the side here, but I'm just going to put a negative. Each one of these is going to be negative. You still cannot plug in 0. That's going to be an asymptote in this situation too. And otherwise, the values, they're identical to what you had in the table right next to this. They're just negative instead of positive. Okay, so all that's going to do to the graph, it's going to take those two branches and it's just going to flip them upside down. So it's going to be almost the same graph, it's just going to go and point down instead of up. So if I do like my -2, now I'm at -1/2. -1's at -2, -1/2 is down at -8. Just kind of estimate, it doesn't have to be perfect if you got a decimal going there. And the other branch, just like the previous question, should just be a mirror image over the y-axis. So in this case, both of these branches point down. So anytime you get an x squared in the bottom, it's going to cause the branches to flip the same direction. If we just have an x, it's going to be like yesterday where they were diagonal from each other. I'm just going to draw these in real quick. Now, the difference here, I know I didn't leave a bunch of space. The domain here, just one branch goes left, one branch goes right forever. You just don't touch this one in the middle. So all the numbers, but not 0. And then here, the range, this always throws people off when it points down. But when you do the interval, you got to go from the bottom to the top, right? So these branches both point down forever. So this would go down to -infinity. So when you write your interval, you have to start it with the lowest possible value, which is -infinity here. And then the asymptote stops the graph. You don't have anything above that. So the asymptote there, 0, is going to be where the graph is actually stopping its range. There's no positive values on that graph. Does anybody have any questions? Okay, so I'm just going to label this on the graph real quick, and I can draw it too if you want me to. But this first graph we did, these branches would be in quadrants 1 and 2. So if that number on top is positive, you got an x squared in the bottom. You're going to be in quadrants 1 and 2. The second graph we did is if a negative number is on the top and an x squared on the bottom. So that puts it in quadrants 3 and 4. So in general, and this could be, you can use this for your shifting after you do your asymptotes, but in general, if the k value is positive, you're going to be in quadrants 1 and 2. If the k value is negative, you're going to be in quadrants 3 and 4. The rest of what we're going to do today is shift these graphs, and it's going to follow the same rules as yesterday. So just at the bottom of the page, I'm just going to jot these down for you here real quick. Very similar. The difference is instead of just x minus something or x plus something on the bottom, it's going to be in parentheses and squared. You are not going to FOIL or do anything like that. That would be a lot of extra work that we're not requiring. So we're just going to go ahead and leave it in that factored form. But if it's squared, that's how you'll know they go the same direction. But same rules apply. So whatever's with the x is going to shift the graph either left or right, and it'll be the opposite way that you think. So if that looks like x minus 5, it actually goes 5 units to the right. If you had x plus 4, it would actually go 4 units to the left. And it's what would set that equal to 0, which is where we're going to have a problem on the graph because I can't divide by 0. So it's going to be the opposite of what that looks like. And then, let me grab a different color. Whatever's to the side of the fraction, like completely not involved, like with the x is going to affect the x. Outside the fraction, we're going up or down. And this will just be the way you think. So like if it's plus 3, it's going to go up 3. If it's minus 5, it's going to go down 5. And those will affect your asymptotes there. Okay, so then on the back here, excuse me, I just have a tiny little summary, kind of like we did yesterday, but this is not going to be like yesterday where they were exactly the same. These are different. Okay, so in this scenario, this gives you a shifted version of the formula that I was talking about on the front. So we'll have like x plus or minus something and then something to the side. If the k value is positive, just in general, both of the branches are going to point up. Right? That squared is going to flip all the coordinates to go the same direction. So they'll both go up like a mirror image of each other over your asymptote. Now, the x, the vertical asymptote, so whatever x equals, this would be a vertical line, is going to be whatever that b value is. The y is going to shift the graph up or down, and that's going to be your horizontal asymptote. That'll just be the number that's added or subtracted to the fraction. Okay, domain is the same as yesterday. It's all real numbers, but it will not be whatever your vertical asymptote is, which would be the b value out of that formula. The range is the thing that's different. So for the range here, this is going to be an interval today because the graph would only point up. So the range would start with whatever your horizontal asymptote is. That's going to be c, the way that formula is laid out, and then everything points up forever. So that would go up to infinity. If the k value, so the number on the top of the fraction, if it's negative, that's going to cause both of the branches to point down. And the asymptotes are going to be the same, b and c. B for your x equals b will be the vertical line, y equals c will be your horizontal line. Now, your domain here is the same. It's going to be all real numbers because you're going to go, one branch will go left, one branch will go right forever, but you won't touch whatever the asymptote is in between the two, which will be b. And then this one, the range is always tricky. It points down forever. So the lowest possible value your graph would reach, we'd have to write that as negative infinity. And it actually stops at the asymptote. That's the horizontal line. It would be c, the way that formula is laid out there. So this is a little different than yesterday. Okay, so we're just going to shift these. We're just going to sketch. You do not have to plot specific points. All right, so pay attention to the number on the top. That's just going to tell you whether the branches should both go up or both go down. If I have a positive 8, literally the only thing that I'm going to use that for, if that's positive, then I know both of my branches are going to go up. That's literally the only thing you need to use that for. We're not going to plot specific points. I'm just going to have you do the asymptotes and sketch the branches in. Okay, so if on the bottom we have x minus 1 squared, and then to the side of that I have a 2. Can anybody tell me, like, what would the vertical line be, or how would that x minus 1, how would that shift the graph if we just had like y equals 8 over x? If I did 8 over x minus 1, how would that minus 1 move the graph? Right, exactly. So this -1, so we're just going to go right 1, and so that's going to be your vertical asymptote. X is going to be 1. If I plug 1 into the bottom of that fraction, right, it makes it 0, and we can't divide by 0, so that's why the problem is there. Now, the +2 to the side, I don't know why I just wrote the word right and didn't write 1. There we go, right 1. The +2 on the outside, that moves the graph up or down. If it's +2, we're just going up 2. That's it. Okay, and that would correspond to a nice horizontal line at 2. So I'm just going to draw the asymptotes in there real quick. So x is 1, nice vertical line right here. Y is 2 right here. Now, both of the branches, because it's squared on the bottom, don't FOIL it or anything, but it's squared on the bottom. That's what's going to tell you the branches are going to go the same direction. So we're just going to sketch this. And it doesn't have to be perfect, just do your best to not draw it over the asymptote. Your domain, you're going left and right forever, but you're not touching the number in between the two branches, which should just correspond to whatever you wrote down for your vertical asymptote. So I'm going to say all the real numbers, but not 1. And then the range here is the one that's a little trickier. It's an interval. So both branches point up. Okay, so my lowest possible value that I don't actually touch is going to be my horizontal asymptote. So that's going to be 2. So I'm just going to do a parenthesis, 2. And then both of them point up forever. So 2 to infinity would be a description of your range for that graph. All right. Now, if I look at the one right next to this, again, just look at the number on the top real quick. That'll tell you what quadrants that your branches should be in. So if this is -4, we're both going to point down. If we've got an x squared or a parentheses that's squared in the bottom, the squared is going to cause the branches to go the same direction. Okay, now, this guy, let's see what we're doing here. X plus 1. So this is actually going to go left 1, because if I plugged in -1 to the bottom of that fraction, we would be dividing by 0, which is not okay. That's going to give us an error. So that's going to be our asymptote. And then the y is going to move up or down. That's just going to be to the side of the fraction. This is -3 here, so that's going to shift the graph down 3. So it would just be y equals -3. All right, so I'm going to draw my asymptotes here. I'm going to have a nice vertexal line at -1 and a nice horizontal line at -3. Because of the negative on top, the negative k value, it's -4 for this problem. Both of those branches should point down. So it doesn't have to be perfect. Just try your best to do a sketch. Just kind of hugs in, like the curve kind of hugs into the x and, or the, well, your asymptotes there, your new x and y axis, if you will. Now, your domain, one side goes left, one side goes right forever. They just don't touch the asymptote in between the two branches. So all the real numbers, but not that -1. And that's because we would be dividing by 0 there, and that would cause an error if we tried to plug that in. Now, your range, everybody's going down forever. So my interval has to start with -infinity. Then you're going to tell me where it stops. Like I would stop touching that graph at that asymptote, which is -3. So -infinity, -3, there's no graph above that. Does anybody have any questions? Okay, tiny review from yesterday. So the two questions at the top of example 3, these are actually y equals 5 over x. So this is just a plain inverse variation. This is not an inverse variation squared, because I don't have a squared here. So, and I know you guys had several questions like this on the homework, so I'm just going to practice this one more time. So if I give you the asymptotes, could you transform the equation to tell me what the equation would look like if I give you the asymptotes, or if I give you a description of how I want to shift the graph? So if I'm going to do y equals 5 over x, I'm just going to write y equals, and we'll just keep a 5 on the top. Okay, now on the bottom I have x, and my two asymptotes that they give me, I want x to be 3 and y to be -2. What if I wanted to do x equals 3 and y equals -2 as my asymptotes? What would you put in the bottom of that fraction? Yes, yes. Yes, good deal. Minus 3, the x goes with the x. And it's the opposite of what you think. Now, do you guys see, if I plugged in 3 to the bottom of that fraction, that would be a problem because that would be 0. That's how you could check real quick. But this will be the opposite of what it looks like. So to me, that looks like positive 3. It's x minus 3 in the equation. And then the y, don't worry about doing an opposite or anything with that. The y is just going to go to the side. You just copy that number down to be negative 2. Okay, now I'm just going to try it. This does not have to be perfect. We're just going to sketch this, and I know this is a blank graph, but x equals 3. I'm just going to count over, like, just do like 3 spots, and then y equals negative 2. I just go down 2 spots. And I'm just going to sketch in my asymptote. So I'd have a vertical line at 3, and I'd have a horizontal line at negative 2. Okay, now we'll review from yesterday. So this is just a plain x on the bottom. It's not squared. So we're going to have branches kind of diagonal from each other. If that number on top is positive, this, I don't know why my pen is not working. This is in quadrants 1 and 3. So on the graph here, based on my asymptotes, that would be quadrant 1, and that would be quadrant 3. So there's no squared there to make the x or the y values go the same direction. So because it's not squared, you should have branches that are diagonal from each other. If that number on top was negative, we would just put it in quadrants 2 and 4. Okay, I'm going to do one more real quick. Now, with this one, x equals 0 as my asymptote, you would literally just keep the bottom as y equals 5 over x. Because if I plugged in 0 there, that would be causing me the problem. So I don't have a shift left or right here. I do have a shift up or down. If it's y equals 3, then just to the side of the fraction, we're just going to put a 3. Okay, not going to shift left or right, so I'm going to leave x equals 0 is just the y-axis, so that's going to be my asymptote, my vertical asymptote. And then I'm going to go up 3, so I'm just going to kind of eyeball like 1, 2, 3. And this would be, I'm not flipping what quadrant this is in or anything like that. I still have a positive 5 on the top, so the branches would be in quadrants 1 and 3 here also. If that number on the top is negative, it would be 2 and 4. Okay, now the other one I have here at the bottom, this is what we did today. So this says we're going to translate y equals negative 5 over x squared. Okay, so automatically, because I have a negative 5 and I have an x squared, I know the x squared is going to make the branches go the same direction. If it's negative, then both of these graphs should have my branches so they point down. We're just going to manipulate these based on what they give us, in the directions. Okay, so 2 units to the left, 2 units to the left. The actual asymptote would be x equals negative 2 for that description. Left or right is going to be an x equals. Up or down is going to be y equals. So if I go 4 units down, it would be y equals negative 4. Those would be my 2 asymptotes. I'm just going to plug those into the equation. So the equation they gave me has a negative 5 on the top. Now, in terms of the squared here, you're just going to put in a set of parentheses. We're not going to FOIL or anything like that. You're just going to put a set of parentheses if you shift left or right, and we'll just put a little squared on the outside. It works the same way as it did for the question above. If it's x equals negative 2, it would look like a positive 2 in the actual equation, because if I took and put in negative 2 there, I'm going to end up with 0 in the denominator, which is our problem. And then the y, just put that to the side of the fraction, just going to be a negative 4. And so then if I want to sketch this on the graph, I'm just going to go left 2, and then down 1, 2, 3, 4. And sorry, this graph is like really close to the bottom of the page here. And I'm just going to draw both of those branches should go down. Something like that. I'm just looking for a sketch, and as long as it goes the right direction, we're good. It doesn't have to be perfect. Okay, and I have one last question. This just says 2 units to the right, so that would be x is 2 would be the asymptote. So everything else we're going to do x minus 5 on the, or sorry, negative 5 on the top. That was from the directions. And then if you've got a squared, an inverse squared, x squared on the bottom, just make the bottom of this parentheses if you have to shift it. So it would be x minus 2 squared, and then it doesn't shift up or down on this graph, so nothing to the side. And so 2 to the right, I'm just going to grab this, just go like 1, 2. And then you're not shifting up or down. So the x-axis would be your other axis. So it would be y equals 0. And I have a -5 on the top and a squared on the bottom. Squared causes the branches to go the same direction. The negative causes them both to go down. Is anybody having a question?